Okay, for 92, I got to write the sum down, and it looks pretty strange to me, but let's do this over here. So it's limit n goes to infinity. It looks like a sum. I want to point out what I believe is changing over here. 1, 2, 3, up to n. But everything else looks like it's the same thing. So let's write that down. So I'm going to write down I equals 1 to n, 1 over n, 2 plus I over n squared. And, be careful now. Look at this and say, does it really make any sense to put that down? And I'm kind of looking at it, and let's take a look. So I got the 1 over n every time. Yeah, I think I did okay. Yeah. And it reminds me of of a square, something being squared, by the way. And the length of the interval is still 1. So I'm still gonna start at 0 to 1. Still gonna start there. But then the question becomes is, what's the function? And I'm gonna say it looks like 2 plus x squared dx. All right, before I do anything though, I want to claim that I'm going to think about that before I say that's true. So, 2 plus x squared is a parabola that has a vertex at -2. And it looks sort of like this over here. And we're going from 0 to 1. Okay? So let's take a look at it. And this function over here, I'm going to say f of x is going to be 2 plus x squared. Again, I'm just checking to see if what I wrote down is correct. So what do you get over here? Well, the interval length of it is still 1 over n. And my first rectangle is going to look like this over here, where I move this over here. What's that going to be? 2 plus 1 over n squared. What's the next one going to be? Still is the same base, which is 1 over n, 2 plus 2 over n squared. Yeah, I think I did okay. All right. Now someone says there's another way to write that. There is, but the bottom line is I want to go through the integration. Let me erase this over here. I'm convinced that this is correct. We'll look at the key momentarily. But I want to do the integration. And there's many ways to do it. I'm going to do it by a technique that you should be familiar with at this point, which is a U substitution. So I'm going to write this over here. It's going to be 0 to 1. And that's going to be 2 plus x quantity squared dx. So I'm going to say u is equal to 2 plus x. du is going to be, let's see, dx, right? So let's write this over here. At 0, when x is 0, u would be 2. And when x is 1, u would be 3. And then you get u squared du. So this thing, you go back and put the x in and go, this is really the same thing as 2 to 3, x squared dx. Let's do the integration. You're going to get x cubed over 3, 2 to 3. Let's see, 3 cubed is 27. And then 2 cubed is 8. 27 minus 8 is 19. All right? Okay, that's one way to do it. Let me get my eraser out. I'm going to do it another way. And I'm going to do it the other way because it's really something that a lot of students struggle with. I'm actually going to do the sum now. It's 1 over n. Let's expand it. And again, I want to put what I'm doing this over here. That's going to be 4. Plus, let's see, 2i over n plus 2i over n is 4i over n. Plus, I is a counter, it's not the imaginary unit. I squared over n squared. All right, and it's going to be I equals 1 to n. And let's see what you got over here. Limit n goes to infinity. Let's keep writing it down piece by piece. Sum I equals 1 to n. That would be 4 over n plus 4i over n squared plus I squared over n cubed. Well, I got formulas for each one of those. Limit n goes to infinity. The first guy is going to be 4n times n. The second guy is going to be 4 over n squared times n plus 1 over 2. The third guy is going to be 1 over n cubed. Let's see, n plus 1, 2n plus 1. And I think I can do it. I want to point out why I can do it. These cancel off. That limit's going to be 4. Let's do the next one. I'm seeing an n goes into this one. I'm going to say an n goes into this one. 1 plus 1 over n. So what are we left off with? 2. Wow, that was easy. What's the next guy going to be? Well, I'm going to divide these into each one of those factors. So 1 there. This will be 1 plus 1 over n. This will be 2 plus 1 over n. So what do you get over there? You get what? I made a mistake somewhere. Oh, I forgot the 6. That's what happened. I was going, why is that working out? 6. Sorry about that. And what do you get there? You get 1 times 1 times 2, which is 2. This can be 6 plus 1/3. And 6 times 3 is 18. 18 plus 1 is 19/3. I'd actually prefer to do the integration into sum, by the way. Let's take a look at the work, see if we got this right. Did I get the right integration down? Let's see if I got that written down. I got that one over there. Did I put this one down? I did. It's right over here. They're equivalent. And did I get the sum 19/3? I got the sum 19/3. And we're done. Thank you.